Okay, now we're ready to talk about a really neat algorithm for computing something called the string edit distance. And this is a problem that is very difficult to solve unless you think about it recursively. And if you go a step further and use memoization, you can make a very efficient algorithm. So string edit distance is really, it's a fuzzy way of comparing strings. And what we do is we think, okay, if we have a string S1 and a string S2, the edit distance is the minimum cost sequence of operations to turn S1 into S2. So here are the operations we're allowed to do. So we're allowed to add a character to S1. We're allowed to delete a character from S1. We're also allowed to swap a character from in S1, from one to another. And each of these cost 1 unit of cost. Okay. So all three of these operations cost 1. So the question is, what's the cheapest sequence of operations that I need to perform to turn a string S1 into a string S2? So let's look at a couple examples and just see what we can do. We're just going to try to do it by hand, and then we'll see a more efficient way to do it. So let's say that we wanted to do look at the string Chris versus the string Chase. Okay. So, all right. Let me write these out. C-H-R-I-S, C-H-A-S-E. And what I'm going to do is, okay, I want Chris to turn into Chase, so I'm going to keep a little dot here that shows me what letter I'm on. So does C match with C? Yeah, so I'll keep 2 dots. These are kind of like my little cursors. This one's on the first one of this one. This one starts at the first one of this one. Does C match C? Yes. Okay, good. That doesn't cost anything. So let me go to the next one here, and I can go to the next one here too. Does H match H? Yes. Okay, does R match A? No. So maybe what we can try to do is okay, so let me write down the steps I'm doing. So we match C to C, match H to H. Then let's say maybe we delete R, and this is going to cost 1. So there's a gap here. And then we add A. So that also costs 1. All right, so I add A. Fine, now I can match A to A, I'm good. All right, now let me move them forward again. Okay, I does not match to S, but maybe this time instead of deleting and adding, I'll say, let me swap. I'll say swap I S. What that means is put an S in the place of I. That costs 1. All right, and let's go one more. And I guess this time I also can't match S and E, so I will swap S. I'll swap an E in for an S. So if I look at this, here's a sequence that did it. And that cost a total of 4. Okay. Fine. Can we do better? Well, let's see. So what if I start over and, well, I guess I'll keep that like that. Hang on. Yeah, what if I start over and I'll start with Chris and Chase. But this time, okay, so I'll start off the same way where I match the first 2 and I'll move over. But this time, let me not delete and add, let me actually swap because that only costs 1. So let me swap an A in for the R, that costs 1. And then I can do the other things that I did. So then I'll swap the R in for the A. I'll swap the A in for the R. Then I will swap in the S for the I. Then I will swap in the E for the S. So this one costs a total of 3. And that turns out to be the best that you can do in this example. So going from Chase to Chris, or Chris to Chase, actually it's symmetric. That is going to cost a total of 3 at best. Okay. Cool. Let's just do another example just to make sure we're totally on board with this. So what if we do, let's match school to fools. Okay, so how are we going to do that? They say schools for fools, but that's only if they're a fool, right? Okay. So school versus fools. All right. So, well, it looks like, if I'm kind of looking ahead, it looks like I should probably match these two O's here, right? So maybe, let's see. I guess I'll swap in the F for the S. That costs 1. Then I'll move forward. You know, at that point I can match the new F that's there. That doesn't cost anything. I'll move forward. And actually, I can kind of see, I know this is coming. I better just delete the C, which costs 1. So I'm just going to move this over like that. And then I'm going to delete the H. That costs 1. Okay, now I can actually match 2 O's in a row, which is cool. And I can actually match the L as well. Okay. Oops, I forgot to put the F there. All right, so I'm going to match the O, and the L. Cool. Okay, now I'm not done because I actually do need to add something, right? Because as soon as I move this cursor forward, I see that, okay, I've run off the end of this thing, but I need an S. So I'm going to add an S right past the end of that cursor there, and that costs 1. Okay, so it turns out schools to fools, the best you can do is 4. Okay, we've seen some examples, but how do you do this in general? It seems like it could get to be pretty tough if you have pretty long strings, right? How do you know that if you're doing this ad hoc approach that you're going to get an optimal solution? Well, we can use recursion to help us with this. And what we're going to do is we're actually going to work backwards. So we're going to say, okay, let me see kind of what's the last thing I have to do. I'll assume that I was able to match most of the characters, but let me kind of go to the end. So let's look at Chris and Chase as an example. Okay, so what I can say is there's a few possibilities here. So one possibility is that I was able to match CHRI to Chase. So I don't know how much that cost, but let me assume that I was able to do it somehow, and that this is going to give me the optimal way of matching CRHI to Chase. But what this implies is that I've deleted S from Chris, right? That costs 1. So we're saying that this costs 1 to delete S from Chris. Okay? So one way to do this is to match CHRI to Chase and then delete 1 from Chris. Okay. Another way to do it is to say, well, let me imagine that I matched all of Chris, but to CHAS. Okay, well this is kind of the same thing. This costs 1 to delete E from Chase. So I know this is a little strange because I thought I was only doing things to Chris, but you can also, everything is symmetric here. Remember I said I could get the same cost by transforming Chase into Chris as I could by transforming Chris into Chase. So this is fine. I can think about doing this as well. So I don't know if it's going to be better to do this or to do this. And there's actually even one more possibility here. So I could force myself to swap in the S for the E. So I could say edit CHRI CHAS. Let's say I matched everything but the last character of both of them. But then E is not the same as S, so that means I'm swapping in E for S or S for E. So that's the idea. Now we kind of have a recursive way. So in general, you would write this in code as, the min of, so actually in Python, if you see it say something like this, min 5, 3, 1, cool, in Python you can actually use the min straight like that. So you would say something like min edit, I'm going to write pseudocode because I want you to do the actual code, but min edit S1 from 0 to -1, so I'm taking out a slice of everything but the last character to S2 plus 1, right? Edit S1, but then slicing out the last character of S2 plus 1. And then, now it is possible, so if instead of Chris my name was, or maybe instead of Chase this was Chas, I mean, just to show you another example, this last one wouldn't cost anything because the S matches to the S. So that wouldn't cost anything. So we can also say, let me actually force the last characters to match. But I'm only going to pay a cost if they're different. So plus 1 if S1, -1 is different. Let me put these on different lines here. Plus 1 if S -1 is not, is different from S2 -1. Yeah, so only if that's true. Otherwise, we don't add anything. Okay. So this is basically the code for doing the recursion to compute edit distance. But we don't have a stopping condition, right? Thought I heard somebody screaming. Okay. Good. We don't want infinite recursion. That's like having an infinite loop. So what's our stopping condition? Well, what we can think about is really matching the empty string to a string. So if I say, for example, edit of the empty string to Chase. Well, this should cost as many characters as there are here. The cheapest thing I can do is just add all of the characters one by one in the string that I'm matching to. So that's going to be the length of Chase. So in general, our base cases are edit of the empty string to some other string is the length of S2, and the edit of S1 to the empty string is length of S1. Okay, so now I've given you all the information you need to implement the edit distance. So you're going to do that, and we're going to verify that you actually get 4 for schools versus fools, and that you actually get 3 for Chris versus Chase. So let's give that a shot.